Good afternoon, mathematicians. Tonight we're going to learn how to graph the equation of a line. In tonight's problem we have, Mr. Gonzalez wants to build a fence around his pool. For every 1 foot of fence, he needs 3 stakes. He uses the equation y equals 3x to help him find out how many stakes he'll need. So what sometimes is helpful to do is to write the equation y equals 3x. And this is going to help us figure out what are the points on our line. What are the ordered pairs? What are the coordinate pairs? So in order to figure out all the different points on our line, I always like to start out with putting in our x points. So we could do 0, 1, 2, 3, 4, 5, 6, 7, 8. We could keep going. But now the question is, how do we figure out what y is equal to? Well, we can plug any value of x into the equation to figure out what y is equal to. So let's see, what will y be equal when x is equal to 0? Well, when numbers are touching a parentheses, it means we need to multiply. So 3 times 0 is going to equal 0. So when x was equal to 0, y is also equal to 0. So now I can fill that in my table. Okay, but what about when x is equal to 1? Let's figure out what that will be. So let's turn this x into 1. So we're going to put 1 inside our parentheses, and we know we have a number inside parentheses and there's another number touching it. We need to multiply. So 3 times 1, y will be equal to 3. So when x is equal to 1, y is equal to 3. Okay, let's keep going and see if we can continue this. What's going to happen for y equals 3x if we decide to make the x 2? What's going to happen there? Well, we're going to multiply. 3 times 2 is 6, so y is equal to 6. I wonder if you're starting to notice a pattern. Well, let's see what y will be equal to when we make our x 3. We multiply 3 times 3, so y is equal to 9. I notice a pattern. We're multiplying our x by 3 to figure out what our y is. So that means when x is 4, y is 12, and when x is 5, y is 15, and when x is 6, y is 18, and when x is 7, y is 21. So it's super helpful to fill out our table before we go ahead and graph our coordinates on the Cartesian plane, on our graph. So what we're going to do now is, based off of the points that we've come up with for x and y, we are going to write the ordered pairs for each of these points. So for the first point that we have 0, 0, and we're just going to make sure we write that the correct way with parentheses and a comma. The next point on our line is 1, 3. We have 2, 6, 3, 9, 4, 12, 5, 15, and goes so on and so forth. So these are going to be the points that we graph to see the equation of y equals 3x. So, since we know that our x is the number of feet of fencing that we're using and y equals the number of stakes we need, we want to graph our first point. So our first point was 0, 0, which is the origin. So we're going to put a dot on 0, 0, and I'll make it a little bit neater to show that that's our first point on the line. All right, we checked that point, we've graphed it. The next point on the line is 1, 3. So when we have 1 foot of fencing, it means we need 3 stakes. There's our dot. All right, well, what about 2 feet of fencing? We need 6 stakes. It's hard to make the dots really nice and neat. All right, when we have 3 feet of fencing, we run 3 and then we jump 9. And when we have 4 feet of fencing, we need 12 stakes. So we're going to graph that 4, 12. Try and make it very neat, but it's challenging. All right, and when we had 5 feet of fencing, we run 5 and then we will jump 15. And when we had 6, we jump to 18. And this line looks like it's going to keep going on forever. The fun part about graphing lines is that at the end you take a ruler and you connect all of the dots and show that this line would continue on forever. So, in order to figure out how many stakes he needs, Mr. Gonzalez can use this graph of a line to help him figure out, okay, well, with 6 feet of fencing, I would need 18. With 5, I need 15. So graphing lines is a great way to help figure out any type of problem in the real world.